Alright, hello class. Today we're going to be talking about section 3.3, which is the product and quotient rules. This stems from the question that we brought up last time, which is basically what is the derivative with respect to x of f of x times g of x. And the natural assumption, or the natural question, is the derivative with respect to x of the product f of x times g of x. Is it actually equal to f prime of x times g prime of x? Okay. And the answer is, of course, no. Right? And because, right? Because if this were true, if this property were true, then the derivative of everything would be 0. Okay, so if this property were true, then the derivative of everything would be 0. Okay, so let me write that down. So the derivative of everything would be 0. And we know that's not true because we've calculated lots of derivatives using the limit definition, even before we were looking at functions, just say finding the instantaneous velocities and stuff, and we got other things besides 0, so we know that this can't be true. And the reason this is true is mainly because if you're taking the derivative of whatever, say the derivative with respect to x of x squared, which we know is actually 2x, but keep in mind, x squared, or everything, no matter what we look at, is actually has a 1 sitting out front, right? We always have that 1 times x squared sitting there. And if we use that bogus property that we looked at or asked about, if the product rule was just the derivative of 1 times the derivative of x squared, then we would get that the derivative of x squared is 0 times 2x, which is 0. Okay, but we know that the derivative of x squared is actually 2x, right? So we know for a fact that this property can't be true, right? So this is the derivative of f times g, f prime times g prime. The answer is absolutely not. And it's because of this, that if it were true, then the derivative of anything, right, we could do this instead of with an x squared, we could do it with just any f. Right, the derivative of f would be the derivative of 1 times f, and we would end up getting 0, and we know that that is not going to be true. Okay. So the question is, what is the derivative of a product? And, well, the answer at first may seem a little counterintuitive, but essentially the derivative with respect to x of a product, f of x times g of x, provided we know the derivative of f and g, is actually going to be f prime of x times g of x plus f of x times g prime of x. Okay, so basically it's a sum, and we take the derivative of the first piece, and then in the second one we take the derivative of the second piece. Okay, so let me show you where this comes from. Basically, if I say that p of x is the product f of x times g of x, and I look for f prime of x, right, I'll end up getting the limit as h goes to 0 of f of x plus h, whoops, and that should be p of x plus h minus p of x all over h. And filling that in with the product, I'm going to get that this is the limit as h goes to 0 of f of x plus h times g of x plus h minus f of x times g of x. Okay? All over h. Now, the thing is, if we were to split this limit up, we would not actually get the derivative. We would just have an x plus h in f and g over h, and an f of x and g of x over h. So what we actually do, it's a very tricky algebra trick that actually helps us. It's kind of like the conjugating factor, where you multiply by a special version of 1 that helps you out. Here we add by a special version of 0. So what we're going to do is I'm going to subtract a g of x plus h times an f of x, and I'm also going to add it. Whoops, it should be the same thing, g of x plus h times f of x. Right, and then I will have minus f of x, g of x. And note that these two things cancel, so this is essentially adding a 0 on the inside. And again, if you're having trouble following this, don't worry. We only have to do this once, and we get the rule. I'm just showing you where it comes from and how we get it from the limit definition. But from here, all we're going to do is I'm going to factor this group and this group separately. Okay, so I'm going to factor a g of x plus h out of the first group. So let's do that down here. So I'll get, this is the limit as h goes to 0 of the f of x plus h minus f of x times g of x plus h. Okay, and I'm going to go ahead and split up the fraction. Well, no, I'll do that next step. Okay, then out of this piece, oh, you can't see it anymore. Out of this piece, I'm going to factor out a f of x. Okay, so this will be f of x. And what's left is a g of x plus h minus a g of x. And all over h. Okay. And from here, right, now I'm going to split up this fraction. Right, and then I'm just going to associate the h with the g of x plus h, the f of x plus h part. So this ends up being the limit as h goes to 0 of, I'll get f of x plus h minus f of x all over h times g of x plus h plus f of x times g of x plus h minus g of x all over h. Okay, and what does this look like? Well, this should look like f prime of x as h goes to 0. And as h goes to 0, this, well, h is going to 0, so this goes to g of x plus 0, which is g of x. This is simply f of x. And then this thing, as h goes to 0, is going to g prime of x. Okay? So we end up getting that this is basically f prime of x times g of x plus f of x times g prime of x. Okay? And so that, ladies and gentlemen, is the product rule. Okay, so the product rule basically says that if we know f prime of x and g prime of x, okay, then the derivative with respect to x of f of x times g of x is f prime of x times g of x plus f of x times g prime of x. So it's the derivative of the first guy times the second guy left alone plus the first guy left alone times the derivative of the second guy. Okay? So this is the rule that you should have memorized. All right, so let's look at an example of how this works to give us an idea. Okay, let's start with a simple example here. Let's say I have y equals x squared times 5e to the x. So essentially what I'm going to do is identify my first function, I'll call this f, and identify my second function, which I will call g. Okay, so when I go to take the derivative, dy over dx is going to be, well, it's going to be the derivative of the first, so derivative of the first function, well, x squared is my first function, so the derivative of that is 2x. Okay, so that's f prime times the second function left alone, right? The rule we look at is f prime times g plus f times g prime. Okay. So it would be the second guy left alone, so I just write that out. Plus, okay, now it's going to be the first guy left alone, right? So first guy left alone, x squared, then times the derivative of the second. So this is just our f left alone, and then the next piece is going to be the derivative of the second function, which will be 5e to the 5x. Right, so that's g prime. Okay. And that's that, other than simplifying it just a little bit by saying that this is 2x e to the 5x plus 5x squared e to the 5x. And you can simplify a little further by factoring if you want. Again, this is good enough for me right here, but if you decided to factor, you could factor an x e to the 5x out, and you'd be left with a 2 plus a 5x. Now again, this step isn't necessary here for the Chapter 3 material, Chapter 3 tests. You know, all you've really got to do is take the derivative and stop. In Chapter 4, we'll actually want to simplify this out and solve and whatnot. But for right now, just take the derivative and move on. Okay. Let's look at another example. Okay, here's our next example. Y equals x squared plus 3x, all times x squared minus 2x plus 5. Now, this should look familiar. In fact, the last lecture we did this problem using just the power rule because we simplified, multiplied this all the way through, and got it down to just powers of x, then took the power rule of everything. We got 4x cubed plus 3x squared minus 2x plus 15. So let's use the product rule on this guy and see if we end up getting the same thing. Okay, so this is going to be my f here, this will be my g. So when I go to take the derivative, dy over dx, it's going to be the derivative of the first guy. So the derivative of the first guy will be 2x plus 3 times the second guy left alone. Okay, so here's my f prime, here's my g left alone, plus the first guy left alone, which would be x squared plus 3x. Okay, so that's f. Then times the derivative of the second, which will be 2x minus 2. That's g prime. So really, you take a derivative, then the next two pieces are really just copying stuff down. Right? You copy down the second function plus copy down the first function, then you take the derivative of the second function. Now, this may not look like what we had last time, right, which was this nice little function here, 4x cubed plus 3x squared minus 2x plus 15. But if we were to expand this out, we would actually get the same thing. So we can do that really quick. But we can really just stop here. Right? You use the product rule. It's perfect. Go ahead and move on. But just to clarify that we get the same thing, let's expand this out. Okay, so distributing this out, when you distribute the 2x, you'll get 2x cubed minus 4x squared plus 10x. Then you distribute the 3 and you get plus 3x squared minus 6x plus 15. And then I'm going to distribute this piece out. So when you distribute the x squared, you'll get plus 2x cubed minus 2x squared. Oops, sorry. No, that's right. Okay. Then I distribute the 3, so I'll get plus 3x squared. Sorry, plus 6x squared. And then minus 6x. Okay. So if we simplify this down a bit, okay, I get 4x cubed, okay, then a negative, okay, so let me just go in steps here. So this will be negative 6x squared. So then plus 10x, then plus 9x squared minus 12x plus 15. I'm going to do vertically, then horizontally. That's just how my brain likes to do things. So this will be 4x cubed. Then when I join my x squareds together at the end, this will be plus 3x squared. Then 10x minus 12x will give me minus 2x. And then I have, whoops, plus 15. Okay. And there we go. That's exactly what we got last time, if you can see. Okay. Now, again, you wouldn't really show this work on a test, for example, unless you were doing this on your homework and it told you to expand out your final answer or whatever. But typically, when you take the product rule, you stop right here, which means the problem has really become one step versus the 3 or 4 that it was previously, especially considering you don't have to do this mess right here. Okay, so let's actually look at an example that might help us verify this problem. So let's say, because I've given you all this information, but we haven't really looked at it. I mean, we have looked at an example that we can check, but let's look at a simpler example, and just to clarify that this actually works. If I look at y equals x cubed, okay, I know that this is x times x squared. Fair enough? Now, using the power rule, I know that the derivative of y with respect to x is 3x squared. Okay. Now, let's try this with the product rule. Let's say I take the derivative with respect to x of x times x squared. And using the product rule, it would be the derivative of the first, which is 1, times the second, left alone, plus, okay, the first guy left alone times the derivative of the second. So we would end up getting x squared plus 2x squared, which is 3x squared. So we end up getting the same thing. Okay, if we use that bogus product rule that we might think is true, right? If we just say that this is the derivative of x times the derivative of x squared, we actually get that this is 1 times 2x, which is 2x, which does not equal either of these. So this is the one that's incorrect. So we have two properties showing us that the derivative of x cubed is 3x squared. And this also brings us to the idea that it really doesn't matter what method you use in a lot of these problems. We'll have a lot of possible methods to tackle these problems, and which method you use is essentially up to you. Okay, it's, you know, often your own discretion. For example, here, of course, if you were given x times x squared, the simplest thing to do would be to just turn that into x cubed and use the power rule. But if you wanted to use the product rule, it's perfectly fine. Another thing I see a lot of people do is they'll see y equals 5x to the 10th, and they'll use the product rule. But remember, you don't need to use the product rule because the derivative is actually just going to be 50x to the 9th using the power rule. But if you were to use the product rule, okay, I see a lot of people do that because it'd be the derivative of the first guy, which is 0, times the second guy left alone, plus the first guy left alone times the derivative of the second guy, and you see that first term just disappears completely. There's no reason to actually use the product rule when you're multiplying by a constant. Okay? Okay, I get this question a lot, this next question here. So what about if I have three things multiplied together? Okay, a pretty common question. So I have an f times a g times an h. So what you do here is you collect two of them and make that the first guy. Okay, so using the product rule, this would be the derivative of the first guy, which would be f times g. Okay, which in turn will be a product rule. So this is essentially a product rule within a product rule, right? Then times just so that's clear, times h left alone. Then it will be plus f times h times the derivative with respect to x of h. Okay, so and then this, the derivative of the product here, that's going to be another product rule. So that's going to be the derivative of the first, which is f prime, times the second left alone, so f prime times g, plus the first guy left alone, f, times the derivative of g, and this whole thing is times h. Okay, and then, whoops, not equals, we will have plus f times, that really should have been a g there, I'm sorry, f times g times h prime. Now this doesn't look like much yet, but let me distribute this h across and we'll actually get that this is equal to f prime times g times h plus f times g prime times h plus f times g times h prime. Okay? So check out what's going. We have the same sort of sum, the same sort of pattern. The first term of the sum is just the derivative of the first piece. The second term of the sum is just the derivative of the second piece. And the third sum, or the third term of the sum, is just the derivative of the third piece. So we have a sum of pieces of products. It's all f times g times h, but we may have a separate term for each derivative. So we just go down the line, the derivative of the first guy, derivative of the second guy, derivative of the third guy. All right, so this is how the pattern propagates. So if I had 4 things multiplied together, say the derivative with respect to x of f times g times h times I, for example, and I'm dropping the of x's here, but pretend that they are there for now. This is going to be f prime times g times h times I plus f times g prime times h times I plus f times g times h prime times I, then a final piece for f times g times h times I prime. Okay, so it really comes down to just identifying what your separate pieces are. Right, so say I want to take the derivative, let's say y is equal to x squared times 3x plus 2 times e to the 5x. Let's use a different number here, actually. Let's make this e to the 4x. Okay, and so if I wanted to take the derivative of this, it would just involve that sort of triple product rule. Okay, so it would be the derivative of the first guy, which would be 2x, times the second guy left alone, and the third guy left alone, plus, now it will be the first guy left alone, times the derivative of the second guy, which will simply be 3, times the third guy left alone, then plus the first guy left alone, the second guy left alone, then the derivative of the third guy, which will be 4 e to the 4x. Okay, and this is pretty much done, except you can actually simplify some of this stuff, make it look a little nicer, but probably factor some things as well, but that's not really necessary as far as I'm concerned. You could just stop right there. But it looks nicer if it's 3x squared e to the 4x. That's really the main difference here. And we're pretty much done. Okay. Now, some people will ask, well, why can't I just expand this problem out? And you can. Okay. So you could just say, well, this is 3x cubed plus 2x squared. Okay, and just use a single product rule. You could do that. Okay, that's perfectly fine. But then if you expand further and say that this is 3x cubed e to the 4x plus 2x squared e to the 4x, well then you can't just use the power rules here, because you'd have to use a product rule here and then a product rule here if you actually wanted to, take this derivative. And since you're already going to have to use a product rule anyway, you might as well just do one product rule instead of 2 product rules. Okay. All right, now let's take a look at the quotient rule. Okay, so up next is the quotient rule. If we know f prime of x and g prime of x, then the derivative of f of x over g of x is, well, it's f prime of x times g of x minus f of x times g prime of x. That looks a lot like the product rule, at least it should, all over g of x squared. Okay, and I like to write it without the of x's just because it looks a little cleaner. It's the derivative with respect to x of f over g is f prime times g minus f times g prime all over g squared. And I always think of it, another way I like to think of it is if I have the top over the bottom, right? There's a top function, there's a bottom function, and it's going to be the derivative of the top times the bottom left alone minus the top left alone times the derivative of the bottom left alone. or excuse me, derivative of the bottom, just in general, all over the bottom squared. And much like how I talk about the product rule in terms of first and second, I could write that even out for you, the product rule. If I have the derivative with respect to x of the first function times the second function, right, it comes out to be the derivative with respect to x of the first times the second plus the first left alone times the derivative of the second. Okay. All right, now how I remember the product rule is I always, because with the quotient rule, with the product rule, it doesn't really matter which derivative you take first, since you're summing, it doesn't really matter. With the quotient rule, it does. It definitely matters which one goes first. You have a minus here, and since you're subtracting, it's going to change things. So remember, the top goes first. You're taking the derivative of the top first. All right, and to show where this comes from, it's basically using the product rule to help us out. If I have that q of x is equal to f of x over g of x, well, all I do is multiply by g of x. Right? So that I get q of x times g of x is equal to f of x. Okay. Then we take the derivative of both sides. Which we can do. You can take the derivative of both sides and keep equality. And then we use the product rule on this side. So this would be q prime of x times g of x plus q of x times g prime of x is equal to f prime of x. Now what I'm actually looking for, you might be wondering what I'm doing, I'm actually looking for this q prime, right? Because q prime, I want to find the derivative of q, right? So find q prime. So I'm just going to solve. So I'm going to move this over and then divide by g. Okay? So I get that q prime of x times g of x is equal to, right, it will be f prime of x minus q x g prime of x. Now, what was q? Well, q was f of x over g of x. So let me go ahead and write this as f of x over g of x. Okay, and that way, when I divide by g of x, I get that q prime of x is equal to f prime of x over g of x minus f of x times g prime of x over g squared. Okay, and the reason it's squared, I already have a g there. I'm dividing both things by g. And then, to get a common denominator, all I do is multiply by g of x on the top and the bottom here. Right, which gives me, finally, once I simplify this, that q prime is equal to f prime of x times g of x minus f of x times g prime of x all over g of x squared. Okay, so this is sort of an explanation of where the quotient rule came from. It's essentially a version of the product rule. Okay. Again, you can also, later there will be another way you can do this, but for now, let's just look at some examples of how to calculate some of these derivatives. Okay. let's say I want to take the derivative of x squared plus 3x over e to the 9x. Now you might think, well, why don't we just split up the fraction like we did before? And the reason is because if we did, well, I'd have x squared over e to the 9x, and then that would just end up being, you know, having to do quotient rule twice anyway. So we can just use the quotient rule here. So f prime of x is going to be, well, it will be the derivative of the top. So let's write this out. It will be 2x plus 3. So this is derivative of the top times the bottom left alone, so times e to the 9x, minus, so this is the bottom left alone, minus the top left alone, so that would be x squared plus 3x. Okay. So that's the top, times the derivative of the bottom, which will be 9e to the 9x. So there's the derivative of the bottom, all over the bottom squared. And there we go. So this ends up being, and we could simplify it a little bit, but about the only thing I would do is I'd rewrite this as e to the 18x. The others I would just leave as is and move on. Okay, so let's look at another example. Let's say I have y is equal to e to the x over 3 minus x, let's say, all over 2x squared plus, let's say, 33e to the 2x. Okay. And again, there isn't much for us to deal with, put into these problems yet, other than e's, x squareds, that sort of stuff. But we're going to fix that here soon. But this is going to be a product rule. I have a function over another function. So when I take the derivative, it will be the derivative of the top. The top goes first. So this is e to the 1/3 x. You can think of it like that. Right? This piece is e to the 1/3 x. So when I take the derivative of e to the 1/3 x, it'll be 1/3 e to the x over 3, or e to the 1/3 x. Okay. Oops. Then minus 1. Right. So here's the derivative of the top. Times the bottom left alone. Okay. Minus, so here's the top, or excuse me, the bottom left alone. Minus, okay, the top left alone, so e to the x over 3 minus x, okay. Then times the derivative of the bottom, so that would be 4x plus, then 33e to the 2x, that would be 66e to the 2x. All over, so that would be the top left alone, and this would be the derivative of the bottom, and then from there it's just the bottom square. And that is how we would leave it. Right? Don't try and simplify problems like this, especially quotient rule problems. Most of these you're just going to take that derivative, crank out that quotient rule, and move on. Okay, so here's another example. Let's say I have e to the negative x times x squared plus 7x all over square root of x plus 2. Okay. Now, this problem, well, first of all, you see that we have two things multiplied together in the numerator, so this is actually going to be a product rule within a quotient rule. Okay, so this is product, you can see that, yeah, product within a quotient. Okay. And second, I have this square root of x, so I'm actually going to go ahead and simplify that so that it's x to the 1/2 plus 2. Okay, since I know I'm going to have to take a derivative, I might as well simplify that. Unless you just automatically know what this derivative of square root of x is. Some of you might. There is a pattern there, but if you're not, it's totally fine. So now we're going to take this derivative. So let me start it back over here. Okay, so it's going to be the derivative of the top, and that is going to be a product rule. Okay, so in brackets here, it's going to be the derivative of the top. So it will be derivative of the first, so it will be negative e to the negative x times the second guy left alone, okay, plus the first left alone, e to the negative x, times the derivative of the second, which would be 2x plus 7. Okay, this whole thing here in brackets, whole thing is the derivative of the top. Okay. It just happened to be, just happened to be a product rule. Then what's the next piece is just the bottom left alone. So that'll be x to the 1/2 plus 2. Right. Then minus, so here's the bottom left alone, and minus the top left alone. Okay, so I'll put that in brackets just so it matches. Right, it's the top left alone, and need a bit more room here. Then what comes next is the derivative of the bottom, which will be 1/2 x to the negative 1/2, and that's pretty much it, because that plus 2 will become 0. So this is the derivative with respect to x of the bottom. Then the final piece is just, this is all over the bottom squared, which will be x to the 1/2 plus 2 all squared, and that is that. Okay. So yes, sometimes you might get a product rule within a quotient rule, vice versa. As these rules start getting more complicated, you will end up starting to see rules within rules, but don't panic. With this one, what did we do? Well, all we did was when we went to take the derivative of the top, that ended up being a product rule, so we just cranked that out. And then once we were finished, we put it in brackets and just continued on with the pattern, which ended up being, then we just multiply by the bottom. Then, we multiply, or then we subtract by the top left alone, that part's easy, then the derivative of the bottom, and so on and so forth. Okay. And this will become a little easier once we start talking about the chain rule and whatnot, but for now, that is pretty much possibly the most complicated type of problem we'll see at the moment, because we don't have that much to add into this yet. We don't have sines and cosines yet, so at the moment, that's what we've got. So that'll about do it for this section. I may potentially do an extra examples, but I feel like with these and then what you do in the worksheet in class should probably be enough to get you familiar with the product and quotient rules. But until then, I'll see you next time. Cheers.